Okay, now we're into part 4 of factoring, a special type of factoring. And this is called factoring the difference of squares. And this is basically, it's formula driven. So you can basically go from like one step to the next step by just applying this formula. And how do we know we're working with difference of square? Obviously, you're not going to see problems that says factor a square minus b square. And if you do, the answer is a plus b times a minus b. So basically, what they're saying is that you're going to have the two variable terms expressed as sum and difference, as a sum and difference of each other, right? So because if you use the binomial expression, the FOIL expression, or just to redistribute these factors, like a times a is a square. See how it happens here? It comes about. A times a is a square. A times negative b is negative ab. Positive b times positive a is positive ab, and positive b times negative b is negative b squared. And you see what happened? We have these like terms that cancel out each other because we have a positive negative 1ab and a positive 1ab, which gives you 0. So we're left with a squared minus b squared. Okay, so yep. So let's jump right in. So how would you know you're working with difference of squares? Well, this is how you will know that you're working with difference of squares. Also, first of all, you will be able to it will be two terms. Because it's actually saying the difference of two squares, all right? The difference of two squares. If you look at your text here, it clearly says factor polynomial, factor the difference of two squares. Okay, so we are going to be working with two terms. That's one. Second, right, it will be a difference. The operation will be a difference. Right? Or as you would say, a minus, right? Or a subtraction, right? Right. So it'll be two terms. The operation will be a difference, a minus or subtraction, and you will be able to find the square root of each term. I love difference of squares. It's nice and easy peasy. Yes, I know the word easy is not allowed, but once you understand the concept of factoring and you go through factoring trinomial by, creating them into four terms, grouping, factoring each term, blah, blah, blah. This here is like, breath of fresh air. Right, so these are the characteristics of a difference of two squares, right? It's going to be two terms, check. Operation will be a difference, check. Be able to find the square root of each term, check. All of these must occur simultaneously in order for it to be a difference of square, right? Must occur simultaneously, right? In order to be a difference of square. So for example, if we have x squared minus 4, is it two terms? Check. Is it a difference? Check. Can we find the square root of x squared? Yes, that's x. Can we find the square root of 4? Yes, that's 2, right? And really it's plus or minus 2, plus or minus 2. So here I have my a and here I have my b. So it's x plus 2 and x minus 2. Done. Oh, it's so beautiful. Beautiful. Right? Let's try another one. Let's say I have 4x squared minus 9. Right? Can I find, is it two terms? Check. Is it is it a difference? Check. Can I find the square root of both terms? Yes. Square root of 4 and square root of x squared is 2x, right? Plus or minus 2x. And it's and the square root of 9 is 3, right? So I have my a, I have my b. So it's 2x plus 3, 2x minus 3. Done. Oh, it's beautiful. All right. Now, let's see another one. Let's try x squared plus 49. What you got? What do you think it is? X plus 7. X minus 7. Psych! Nope. 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 Why not? Because it must have these three characteristics simultaneously. Is it two terms? Check. Is it a difference? Is the operation a difference, a minus, a subtraction? Nope. Nope, nope, nope. And can you find the square root? Yes, you can. You can only have 2 out of 3. You only have 2 out of 3 characteristics. So the sums of squares, so this you cannot factor. It says that these are called sums of squares. Sums of squares, right? Sums of squares, non-factorable. Okay, so be very careful. I know this is gonna pop up on an exam for sure, for sure, for sure. Okay, be very, very careful. Sums of squares are not factorable. All right, and I can prove it to you. Let's look at the difference of square versus the sums of square. Here we go. So here, let's say we have x squared minus 49, and we have x squared plus 49. All right, so let's take a look at this. If we were to write this in descending order, we notice that our x term is missing. So we can add a 0x minus 49, right? Also, we can do the same here, right? Plus a 0x plus 49. Now, it could be a minus 0x, or it doesn't matter because, 0 times anything it'll cancel out, okay? So let me show you how it works. So remember, if I'm doing my, because my leading coefficient is 1 in this case, I can just find factors of the third term or the constant term, right? And it's a negative, so that means it has to be a positive or a negative factor. Right? It has to be a positive and negative factor. So, we know that 7 times 7 is 49, and that if we subtract, and we have to have a subtraction involved, and if we subtract this, right? Yeah, we know that because we know factors of 49, 1 of 49, 7 and 7, we know we can't use 1 of 49 because that'll give us 48, because a subtraction must be involved because this is a negative. So my two factors are 7 and 7, right? And we know that if we subtract this, what do we get? 0, right? The middle number. So we know that it's a x plus 7 and a x minus 7. Bam, right? Remember how we did that, right? We have a positive and a negative factor, okay? Now let's take a look at this factor here. We know that this is a positive 49, so it's either 2 positive numbers or 2 negative numbers, right? We have to add to find our middle. Now, what 2 numbers are we adding? That's going to give us 0. Right. That's what I thought. All right. So you see, this is non-factorable, sums of squares. Remember that, okay? All righty.